Here is our program that draws all these random rectangles, which is not yet interactive. Let's make this program react to the mouse. First, let's find out if the mouse is inside that rectangle, and if it is, it will draw a white border around it. So this is the loop that goes through every rectangle and draws that rectangle on the screen. There's many ways we can find out if the mouse is inside one or more of these rectangles. One way to do it is, for example, we could define here a variable called int found, and I'm going to make this equal to -1. And what I'm going to do is here, while I go through every rectangle and I draw each rectangle on the screen, I'm going to compare if the mouse is inside this specific rectangle. And if it is, then I will update this variable called found. And I will store in this variable the number of the current rectangle. Imagine I start here comparing. I draw rectangle 0 and I check, is the mouse inside that rectangle? And maybe it's not. Then I go to rectangle 1, 2, 3, and suddenly when I reach rectangle 7, then it notices that the mouse is inside that rectangle. So then I will store this number, whatever is in the variable I, for example 7, and I will store it here. When I'm done, when I'm finished drawing all the rectangles, then I will check if found has changed. If found is -1, that will mean that it didn't find any rectangle that is under the mouse. But if found is not -1, but a number like 7 or like 23, then it means that this rectangle is under the mouse and it should draw a border around it. So let's type here the condition. I'm gonna say if, and we'll type here for now mouse inside. In that case, I will make found equal to I. So I will store in the variable found the current rectangle number. So I have to now define what is mouse inside. We know this from previous episodes. I can type here these 4 conditions. Mouse x is greater than x1 of I, and mouse x is less than x2 of I, and at the same time mouse y is greater than y1 of I, and finally mouse y is less than y2 of I. So this means that the mouse is inside of this specific rectangle, the rectangle number I. So I have found this rectangle now. It can happen that more than one rectangles are under the mouse. In that case, imagine that both rectangle 7 and rectangle 23 are under the mouse. Then only the last one will be stored in this variable. Why? Imagine I'm going here through all the rectangles, 0, 1, 2, 3. It finds out that rectangle 7 is under the mouse, so it will make found equal to 7. But the loop continues, and then it goes to 8, 9, 10, 11. Then when it reaches 23, it notices again, hey, rectangle 23 is under the mouse, or the mouse is inside rectangle 23. So then it will make found equal 23, replacing the old value. So it will not be 7 anymore, but now it will be 23. After I'm done drawing all the rectangles, now I could draw the border. So I could say here that if found is greater or equal to 0, so that means that I have found one. If it's -1, -1 was the original value, then this condition will be false. -1 is not greater or equal to 0. But if it is anything else, if it's a greater number, then we have found something. So now we could say here that I don't want to fill, and I want to have a white border. So I'm going to say stroke 100. Remember that this time we don't use 255 because we have to find that the colors are defined by numbers between 0 and 100. So this is white. And now I type rectangle x1. And now here I'm not going to use I, but I'm going to use found. Found is the number of the rectangle which is currently under the mouse. So I'm going to say x1, y1 of found, x2 found, and y2 found. And after drawing the rectangle, I could say here no stroke again, so future rectangles are not drawn with a border. Let's try if this works. I missed here a square bracket. And you can see now it's highlighting the rectangle that is under the mouse. Sometimes there's more than one, like here. So you can see that it's drawing the border even if it's below the other rectangle. This is happening because I'm reading the properties of the rectangle which is currently under the mouse, even if it's below some other rectangle. Now we could make that when we click, this rectangle jumps to a new position. So I change the values of x1, x2, y1 and y2. So I can move the rectangles to a new random position. So I could do this here. If this is true, then I have found the rectangle which is under the mouse. Now I could check if the mouse is pressed. So I could say if mouse pressed, then it will do something. Otherwise, I will highlight the rectangle. So this behavior, the one we had right now, will only happen if the mouse was not pressed. But if it is pressed, then let's find out a new position for this rectangle. And we could just copy all these lines here. These 4 lines define the position. So I'm going to copy all these lines where we give a random position to this rectangle, and I'm gonna paste them here. If the mouse is pressed, then let's give it a new random position. But here we cannot use I, we have to use found. Found is the number of the rectangle we are working with at this precise moment. So either we draw a border for the rectangle found, or we give a new position to the rectangle found. So I'm gonna say here x1 found. We have to replace here every I for found. Found here, found. That means that if we have found a rectangle that is under the mouse and the mouse is pressed, then let's change the position of this rectangle. Now let's run the program and see what happens. You can see I can still move around and it's highlighting, and now if I click here, well, it disappeared. Sometimes it will move below some other rectangle. And if I leave the mouse pressed, you can see I can get rid of all these rectangles and I make them jump somewhere else. So I can try to clean here the top of the screen by clicking and moving, and then I'm pushing all these rectangles down. And I can do the same here, and I'm gonna click and move everything up somewhere. So now you have an idea of how you can interact with many objects on the screen. In this case, they are just rectangles. But the idea will be always the same. You will have a collection of objects. In this case, we have arrays of positions for our rectangles. And every time we draw the screen, what we do is go through every single rectangle and draw it. And then we check if the mouse is inside this specific rectangle. Then later, if we found that it is inside some rectangle, then we can do something like draw a border, or if the mouse is clicked, then we can make it jump to a different position.